Nazi weapons program.
That's an incredible structure.
A vast network of research labs, launch pads, and missile silos. And a terrifying weapon unlike anything the world had ever seen before.
It could break the sound barrier.
The world's first ballistic missile.
This changes the face of warfare. This changes the history of the modern age.
I want total devastation, complete devastation.
This is the story of a Nazi genius who built cutting-edge bases to create a revolutionary space-age weapon and the technology that ultimately put men on the moon. The V-2 rocket program. The biggest construction projects of World War II. Ordered by Hitler to secure world domination. Now they survive as dark reminders of the Führer's fanatical military ambitions. These are the secrets of the Nazi megaweapons. Saturday, October 3rd, 1942. A team of Nazi scientists arrive at Germany's most secret military installation to launch a completely new kind of weapon. Leading them is Wernher von Braun. At the age of just 30, he is the world's top rocket scientist. Von Braun's goal is to create the world's first long-range guided missile. A weapon that the Nazis hope will decide the outcome of World War II.
Hauptstufe! Hauptstufe gegeben! Decker gefallen!
It's broken the sound barrier.
Years ago, this looked completely different.
Rocket scientist and V-2 expert Dr. Olaf Zabilski is standing on the very spot where this launch happened more than 70 years ago.
You have to imagine that the trees weren't here. It was all level, partially paved.
This is Peenemünde, a vast Nazi laboratory built to win World War II. In 1942, the Nazis dominate Europe, but the war is turning against them. America, Britain, and Russia are fighting back, and Hitler has pinned his hopes on rockets to pound Britain into submission, as military historian Christian Gustafsson explains.
In Hitler's mind, this is terror. It's about scaring the population. And he feels that he can frighten Britain with this weapon sufficiently to drive them out of the war.
It was a weapon that had its beginnings over 10 years earlier. In the 1920s, teenage genius von Braun was part of an amateur rocket craze sweeping Germany. This history has fascinated Martin Tamar, head of rocketry at Dresden University, all his life.
Rockets became very popular. You had societies forming here in Germany. young people got together trying to build little rockets.
They were fueled by gunpowder. But they were unguided, unpredictable, and only able to travel a few hundred yards. As a weapon, the greatest danger they posed was to the people launching them.
In its early development, rockets were loud. They were certainly colorful and bright and potentially scary for things like cavalry, but they were in no way a significant battlefield weapon.
In the early 1930s, von Braun starts working with a new technology, liquid-fueled rockets. A powerful weapon with the potential to travel huge distances. His work catches the attention of the German army. They ask von Braun to demonstrate his latest prototype.
Mr. von Braun, a moment, please.
The launch is a failure. But surprisingly, the military offer him the funding he needs.
What is your ambition?
I want to get on the moon, to build the rocket that will put the first man on the moon. It's possible. We can do it.
And it's all due to Hitler. When he comes to power in the 1930s, he greenlights almost unlimited funding for military projects.
Hitler is fascinated with scale. He wants big, bigger, biggest. He builds his stadium in Nuremberg for his rallies to be the biggest stadium on the earth. He wants to build the biggest motorway system on Earth. He wants to build more tanks, more aircraft than anyone else in the world has. He is absolutely fascinated with scale.
Hitler starts rearming Germany. And Werner von Braun is asked to establish the world's first rocket base. A high-tech facility where he can build, test, and launch his most recent designs. It will be the Nazis' largest and most secret weapons lab. Von Braun's first task is to identify a remote location where the new complex can be hidden from other countries. He selects Peenemünde on the Baltic coast, a wilderness of dunes, marshes, and forests 100 kilometers from the nearest major town. Christian Muldafer-Wood is the leading expert on what remains of the rocket base.
We're entering the research center area, and here was the first checkpoint. There were fences, there were dogs.
Hidden in the forest are the remnants of one of the largest military complexes ever built.
Peenemünde is a location where the modern science was invented, part of the history of mankind.
It's the perfect place to test rockets for one reason.
The flight had to be documented. for the whole time. And so you need a straight coastline.
The 200-kilometer-long coastline could be rigged with cameras to monitor rockets during flight. With the site chosen, work can begin on the missile base itself. In August 1936, over 10,000 workers descend on Peenemünde. Nobody has built a rocket base before, so they have to start from scratch. The first challenge? Moving men and materials.
As here on the right side, this is a platform. The platform of the tram with a total length of 107 kilometers.
The railway lines still crisscross the site today. The second challenge is housing thousands of workers inside the top-secret base. A small town is built, complete with shops, schools, and even a local club at the complex's southern boundary.
This place had to be so big because the research center was so complex. Otherwise, it couldn't have worked.
The base is the world's first industrial-scale military black site. Over 25 square kilometers, engineers construct labs for nearly 2,000 scientists, missile factories, and launch pads. To keep it all top secret, they plan to design and build everything on site. But this will require a vast amount of electricity. So von Braun builds his own power station, as rocket physicist Professor Martin Tamar explains.
Well, it's really terrific. It was one of the largest power plants that were built in the late 1930s just to supply a research center. 30 megawatts of power. Most of that was used to make a rocket propellant, liquid oxygen. That gives you unlimited possibilities.
"75% of the energy produced goes to a vast liquid oxygen plant that manufactures the vital rocket fuel. As big as a football field, the liquid oxygen factory produces 13,000 kilograms of fuel per day, enough for 3 V-2 rockets.
This place was definitely groundbreaking. So you had facilities, you invented facilities that didn't exist before.
The rocket isn't the only scientific marvel. So is the technology required to design it. The site's wind tunnel is the first in the world that can simulate the missile's incredible speed.
Just imagining a supersonic wind tunnel, Mach 4.4 speeds, you couldn't think about such kind of facilities before.
The final cost of Peenemünde is a staggering $500 billion in today's money. By 1938, the facility is operational, and full control is handed to Wernher von Braun. But away from the isolation of Peenemünde, events are about to give added urgency to von Braun's work. Hitler is planning to plunge Europe into war.
There are some key people in the German government who see von Braun's rocket development as a potential key weapon in the war that will come.
After investing billions, the Army are impatient to get their hands on a working missile. But there's a problem. Von Braun's first prototypes suffer a succession of failures. The engines are underpowered, and he can't control the rockets in flight.
Von Braun was struggling with explosions on the launch pad, off the pad, and in the air.
The timing couldn't be worse. Von Braun has just been ordered to demonstrate his latest engine to the Führer himself. At stake is the future of the entire Nazi rocket program.
Mein Führer, we believe that a rocket could reach a speed of 5,000 kilometers per hour in only 30 seconds.
The engine functions perfectly.
Meine Herren, das nächste.
But while Hitler continues funding the project, he refuses to prioritize the weapon.
It may seem surprising that Hitler wasn't interested in something so obviously futuristic and cutting edge, but a strategic rocket force is well beyond what Hitler thinks he needs.
In September 1939, Hitler's armies invade Poland. The Second World War has begun. Within a year, most of Western Europe has been occupied. Hitler's faith in conventional weapons has been proved correct.
When Hitler does invade Western Europe, he does it in a matter of weeks, and he does it with, effectively, a conventional army. Tanks, infantry, airplanes operating in cooperation. Why does he need any more strategic weapon? Why does he need rockets?
Von Braun is determined to prove the Führer wrong and continues to push ahead with designing a functional flying missile. Every test is filmed by a camera crew, and with no computers to simulate launches, the only way to test a rocket is to do it for real.
We're here in the Holy of Holies at Peenemünde. This is where they wanted to prove whether their rockets could fly.
The launch site is surrounded by huge banks of earth and reinforced concrete to protect the scientists.
Ist durchgeschaltet. Lüftung klar, Zündung klar, Vorstufe klar.
The rockets are supposed to take off and fly along the coast. But launches often go dangerously wrong.
This is a fire extinguisher, or rather a hydrant for extinguishing the possible explosion.
As well as risking lives, every rocket failure destroys thousands of valuable components. So the engineers spend weeks setting up each test.
Before a rocket could be launched, in case thousands of scientists were blown up, it had to be prepared.
The launch pad is in the center. Next to it is an engine test area with a flame pit, faced by a concrete observation bunker. A railway ferries the rockets to the launch pad from a preparation hangar as tall as a 7-story building.
The rockets were hung in a test building. The electrics and electronics were checked. When they were okay, it was ferried on a rail-like runway into the testing area that we see over there. The testers sat in this bunker. They could only see through periscopes, but there were remote cameras running to show whether the functionality and the test runs were correct. That's the remains of the flame pit for the static tests. Here you can discern the slope for the trench where the gases were expelled. The water would be taken with it. It was 10 meters deep here, and the same in the other direction. We find ourselves on the launch pad. If it all worked, and the scientists in the bunker pushing the buttons and pulling their levers were happy as children because their baby was successful, then the rocket was set down here. The excitement reached its climax just before the rocket was launched, when the relays were laid out and one hoped that it would be successful.
But success is proving elusive. In the summer of 1942, the first 3 test launches are failures. Many more would follow.
It was a step-by-step and trial and error. It was a very difficult task. Examining all the remaining parts, so you check for every piece of evidence to identify the specific cause of the failure.
Von Braun has 2 major technical problems to solve. The first is creating an engine that can power 13 tons of metal at 3 times the speed of sound, carrying enough fuel to travel a distance of over 200 kilometers.
Well, it seems like the rocket goes up very steep and everything seems to look okay. but it seems like probably there's a premature engine cutoff.
Stephanie Cole, an astrophysicist at the European Space Agency, has studied von Braun's rocket engine.
So what we're looking at here is the nozzle and the combustion chamber of a V2 rocket.
There are two fuel tanks filled with liquid oxygen and an alcohol mixture. These two fuels are then forced together inside the combustion chamber.
It's a little bit like a sprinkle, so it actually sprays all the fuel and the oxygen.
The mixed fuel is ignited, but this creates enormous temperatures that threaten to melt the engine. To prevent this happening, von Braun devises an ingenious cooling system.
Werner von Braun had a very clever engineering solution. He used the fuel to cool the engine. The nozzle and the combustion chamber was actually double skinned, so you can see that quite nicely here. So I can actually put my finger between the outer skin and the inner skin.
Cold fuel flows inside the double skin, absorbing excess heat before entering the combustion chamber.
So this is really innovative because you don't need an extra cooling system.
Using fuel to cool the engines becomes the standard for rockets in the future, including the space shuttle's main engines. Von Braun's next problem is keeping the rocket stable and on course once in the air.
Well, as you can see, first the rocket takes off. Looks okay, but then immediately you see how it starts to roll and tumble. So it seems like there is a guidance and navigation problem. It goes off in the wrong direction.
At the time, there is no way to steer a rocket from the ground. So to keep his rockets on course, von Braun has to invent a kind of automatic pilot.
In order to hit the target, they couldn't control it remotely, but let the rocket fly itself.
The system uses gyroscopic sensors, which detect the direction that the rocket is traveling in. These sensors then send electrical impulses to 4 rudders, which steer the rocket. To maintain the rocket in its flight path, these black rudders, these Strahlruder, influence the exhaust jet. Just think of a stream with a plate that applies pressure and by doing so creates a moment along the plane of the rocket, thus steering it in the right direction. After years of research, von Braun finally believes he has a rocket that will work.
Die Steuerung klar ist klar. Triebwerk klar ist klar.
Saturday, October 3rd, 1942.
Zündung klar, Vorstufe klar.
Von Braun and his army paymasters await the launch of his latest prototype missile.
Hauptstufe! Hauptstufe gegeben! Decker gefallen!
It's exploded.
No! It's broken the sound barrier.
Very good.
Yes, but will it reach the target?
Do you realize what we've done? The spaceship is born!
Yes, indeed!
If you think our headaches are over, I'm telling you, they're just beginning!
In complete secrecy and unknown to the Allies, Werner von Braun has created the first ballistic missile. He's launched a 13-ton rocket through the Earth's atmosphere and over a distance of 240 kilometers, eventually crashing into the Baltic Sea. And he's close to delivering Germany's military a much-needed boost.
By late 42, 43, the war is not going terribly well for Hitler. His shock invasion of Russia is starting to bog down, and he is hemorrhaging troops and equipment and money into Russia. Worse, the Japanese have bombed Pearl Harbor, and this has brought the Americans into the war against the Axis. An increasingly desperate and self-deluded Hitler starts talking mysteriously about these wonder weapons, which will somehow pull Germany out of its extremely dire situation.
One of these wonder weapons is von Braun's rocket. In July 1943, von Braun and his army chief, Dornberger, are summoned to meet Hitler.
Achtung!
Heil Hitler!
I'm told you've made some useful progress, Dornberger. Is that correct?
Yes, my Führer. Von Braun will explain.
Bitte.
What you can see here is the first projectile to be launched into outer space. Within 30 seconds, it is traveling at around 5,000 kilometers per hour. It can strike London within 3 minutes. Its warhead contains 1 ton of high explosives.
We need a bigger warhead.
A bigger warhead may not be possible, my Führer.
I want total devastation. Complete devastation.
Von Braun becomes a victim of his own success. He wants Hitler's attention, and now he's got it. The Führer instantly demands thousands of these weapons. He demands V2s to be produced at a rate orders of magnitude greater than what von Braun is capable of producing.
What the Führer doesn't realize is that he has seen the only successful launch of the rocket. Von Braun faces a race against time to perfect the technology. And his job is about to get even harder. In 1942, British intelligence receives numerous reports of mysterious flying objects in the Baltic. Their suspicions about a rocket program are confirmed in 1943, when high-ranking German prisoners are overheard speaking about rockets. Photo reconnaissance planes are immediately dispatched to the area and photograph Peenemünde. Now Allied bombers are closing in on the Nazis' top-secret base.
Good evening, Herr Direktor.
Good evening. Do you have a cigarette for me, please?
Yes.
Is that the artificial fog?
Everyone take cover!
Peenemünde is under attack from over 500 British aircraft. The top-secret base is no longer secret.
We've got to save the planes!
10 years of work by thousands of people is going up in smoke. The Allies hope that the raid will set back the rocket by months or even years. If project leader von Braun is killed and his work destroyed, the program will be stopped in its tracks. Over 1,800 tons of bombs rain down on Peenemünde.
Here was the impact, and this impact caused this hole here, this crater.
The enormous size of Peenemünde makes it an easy target for Allied bombers.
Once the British intelligence establishment works out what Peenemünde is, it's a sitting duck. It's all above ground, and there's very little the Germans can do to protect it from the massive Allied air superiority.
Von Braun survives, but Peenemünde is no longer safe. It's impossible to defend from aerial attack. His rocket research center will have to move out of reach of Allied bombs if it's going to achieve its aim of flattening London. Engineers immediately scout for new locations deep inside Germany. But where can they hide the giant rockets and all the equipment needed to manufacture them? The answer lies in an abandoned mine in central Germany called Mittelwerk. Jens Christian Wagner is the world's leading authority on the site.
Right here in the middle of Germany, there was a huge underground tunnel system which had been constructed since 1936. It was a gypsum quarry. Nazi officials decided to change this into an underground rocket factory.
Peenemünde was this incredible center of science and technology, and now they're trying to do the same thing in Mittelwerk, which is a dark, wet cave.
It's a massive undertaking, and the increasing success of Allied forces is draining German resources.
To build a new factory, the Germans are going to need a large labor force. But at this point in the war, there is a huge labor shortage in Germany. There are simply not enough skilled workers to make the factory work.
Von Braun's quest to build a new rocket now takes a dark and terrifying turn.
From the beginning on, it was planned to send concentration camp inmates as forced laborers to construct this underground factory. They arrived right here where we are now standing, and they entered the tunnel system.
"7,000 slave laborers carve out 2 parallel tunnels over 6,200 feet long. One holds a road and double-track railway for supplies. The second contains machinery to build the rockets. Connecting them are 46 smaller tunnels, each 600 feet long. In all, there are 13 kilometers of tunnels with a floor space of 1 million square feet.
This is part of the production assembly line of the V2. So from the perspective of the Nazis, this was very successful. This factory was finished in 4 months.
But just as the factory finally begins to produce rockets, von Braun suddenly finds himself with a new master.
As the war is going increasingly poorly for the Germans, the SS make power grabs throughout the military establishment. One of the objects of these power grabs is von Braun's V2 program.
SS General Hans Kammler made his name by increasing the efficiency of the cremation ovens at Auschwitz.
Hans Kammler was ruthless. He was an engineer of destruction.
Now he takes control of the entire factory and its staff of slave laborers. Von Braun is ordered to focus on the design flaws and leave the manufacturing to Kammler. Production increases from 50 rockets in January 1944 to 437 in May. But these rockets are assembled in appalling conditions, and most don't work.
The first rockets that were thrown together there were bolted and screwed together by unskilled workers and prisoners. They were junk, utter junk.
By 1944, the Nazis desperately need the rockets. The war has turned decisively against them. The Russians are advancing in the east, and Allied aircraft are destroying German cities. Hitler demands 900 rockets per month from Mittelwerk. And Kammler uses brutal methods to increase production.
Many prisoners died, beaten, murdered by SS and civilian overseers. Most of them died by exhaustion, others by starvation. About 10,000 prisoners had to live and to die here underground.
Kammler rushes V-2 rockets off the production line at Mittelwerk. But there is still a huge problem to overcome. Where to build the launch pads and how to protect them.
The Germans can't launch the V-2 from Mittelwerk. It's too far away. They have to move the weapon closer to its principal target, which is Britain, and so they have to launch them from somewhere in northern France.
Hitler ignores army requests for small, undetectable mobile sites and orders the construction of a massive rocket base called La Coupole.
Hitler inevitably gets involved in the debate and, again, almost inevitably chooses the big engineering solution to the problem. He goes for a big static missile launching site.
Beneath a vast concrete dome, the rockets can be prepared and then launched at London.
That's an incredible structure, really.
Arthur van Beveren is a leading authority on German fortifications in Northern Europe.
It's a big piece of concrete. It's the only way up to the dome these days. It's really an amazing structure, 71 meters in diameter, 5 meters thick, 55,000 tons. They laid a huge amount of concrete over the mountain and dug out the chalk underneath it. Building this dome in the way they did allowed them to continue the work inside the mountain while being under constant air attacks.
The dome's size and shape meant that even the largest bombs bounced off it.
You can see a block of concrete over there, which is actually part of the wall where the V-2 rocket came out. And it will be driven towards that flat area over there, and that's the actual launching platform. This would be the place where the trains would go right into the mountains. The V-2 rockets will be on trains, horizontal, and drove right into this tunnel.
In 1944, the Nazis are desperate for working rockets. They're being pushed back by the Allies in Italy and the Russians in Eastern Europe. They plan to stockpile V-2s in these tunnels until they're needed.
We're now entering a part of the tunnel which is normally restricted because it's unfinished and it's kind of dangerous and unstable inside here. The train tracks from the outside would continue deep into the mountain. In total, there were about 7 kilometers of tunnels. And you would have trains here loaded up with V2s, 40-meter long V2s horizontally here. You got guys working, drilling on the sides here, through the chalk. The noise, the stench, the heat. We're now deep, hundreds of meters into the mountain. The V2 rockets needed fuel, which was liquid oxygen. And the idea was that they built a liquid oxygen factory inside this mountain. And it would provide enough liquid oxygen to fire at least 15 V2 rockets every day.
The tunnels of this huge engineering project house hospitals, barracks, and every facility that the crews need to live entirely underground.
You can actually see how they dig through these chalk walls. I can almost do it by hand, here and here. Wow, if it's what I think it is, really looks like one of the drills they would use in 1944. Let's see if it fits. I guess so. Yeah, it fits perfectly. Exact same size as the holes in the wall. That's really unbelievable. Cool. It's amazing to find after 70 years, still inside these tunnels. You can see one of those beams. Don't know if it's a safe plan to go underneath. It's totally rotten.
Underneath the dome, a giant hall is constructed where the missiles can be prepared for launch.
Now entering the octagonal room. Well, room, it's the massive 6-story hall, which is underneath the dome. It's 24 meters high in total, inside the mountain. It's absolutely amazing. The V2 rockets will be brought in from the tunnels, put here, and will be set vertical. And you can see we've got one floor here, one there, and more floors. Every floor had its own crew, for example, fueling and a warhead. Once the V2 rocket was filled, it will be driven outside to the launching emplacement, and it will be fired against London.
The Nazis plan that La Coupole will launch up to 15 rockets a day to smash London. As soon as the missiles arrive from Germany, the British capital will face an unstoppable bombardment. But back at Mittelwerk, the missiles emerging from the underground facility are still plagued by a reliability problem.
The biggest problem we have is the materials and manufacturing quality.
And SS General Kammler is putting extreme pressure on von Braun to find a solution. In the first half of 1944, the Nazi ballistic missile is approaching completion, and Wernher von Braun's rockets are nearly ready to decimate Britain. They are given a name, V2. V for Vergeltungswaffe, or vengeance weapon. There is just one obstacle to overcome. In over 80% of the tests, the rockets launch perfectly. They climb high into the stratosphere. But then something goes badly wrong.
3,000 individual components have to work together, and if a bearing or a relay doesn't work, or a valve isn't properly sealed, the rocket won't fly.
Von Braun didn't understand why the rocket's body was failing.
One factor makes his job even harder. In 1944, there is no technology capable of capturing close-up images of the rocket at high altitude. With the Allies hammering Germany, he makes a desperate last-ditch gamble. He decides to get up close to a malfunctioning rocket as its wreckage falls to the ground. Von Braun narrowly escapes with his life, but finds the answer. The rocket's body has been deformed before it hits the ground.
In order to not squeeze the rocket together, you had a thrust frame, which was a metal frame on top of the combustion chamber, and that frame was transmitting the force coming from the rocket engine into the rocket structure.
He discovers that the structural framework of the rocket and its outer skin are buckling under the extreme pressures of supersonic flight. Von Braun reinforces the fuselage, and the failure rate drops dramatically.
2 years after the first flight, von Braun had finally built a reliable rocket.
V2s begin to roll off the production line. London is only weeks away from bombardment. But in June 1944, the V2 program suffers two huge body blows. The Allies receive intelligence that La Coupole is a possible launching site. It is hit by a succession of massive British bombs.
La Coupole has one major design flaw. Its roof is impenetrable, very, very thick concrete, but the chalk around it is extremely soft. The bombing raids crush all the supporting and logistical tunnels around La Coupole, effectively putting La Coupole out of action before it even fires its first rocket.
Then the Allies storm the Normandy beaches on D-Day.
Just as von Braun is ready to unleash the V2 campaign against Britain, the Allies attack and land in northern France. The sites that von Braun needs to launch his weapon against Britain are threatened by the oncoming Allied army.
Hitler has made a critical mistake. The big static site he demanded was easy for the Allies to attack. In desperation, the Nazis rushed to mount the rockets on mobile launches, as the Army had originally requested.
A mobile missile launcher can be moved anywhere you want it to. It can be hidden in forests or in built-up areas. It offers the advantage of being harder to find.
Steuerung klar ist klar. Triebwerk klar ist klar.
After 14 years of development, SS General Hans Kammler commands the first missile attack on September 8, 1944. The target is London. Hitler's terror weapon is finally unleashed.
What Hitler hopes to do with the V2 campaign is to destroy London and other major cities. He hopes to drive the British out of the war.
In 6 months, over 3,000 rockets are fired towards London, southern England, and Belgium.
If you're a civilian on the ground, you've got this rocket moving supersonically, which you can't hear, and which has been launched only a few minutes before. There's no possible way they can get you warning. There's no way for you to hide. It's an extremely frightening event.
But the V2 has arrived too late to turn the war. By 1945, the Allies are swarming into Germany, pushing the mobile launch sites out of range of Allied cities. The last V2 to hit London explodes on March 27, 1945. If large numbers of V2s had been available 6 months earlier, D-Day may never have happened. But the sheer size and cost of the project meant that it arrived too late to save Germany, and may even have helped defeat it. In total, just over 3,000 rockets are fired, killing 6,000 people at a cost of $500 billion in today's money.
Each V2 on average kills something like 2 or 3 people, but each weapon also costs tens of millions of dollars to build.
The money spent on the rocket program could have bought thousands of mass-produced bombers.
It is a very cost-inefficient way to try and drive an enemy out of a war. On May 2nd, 1945, von Braun surrenders to American forces in Bavaria. The USA now had the brains of the rocket program in custody.
5 days later, the war is over. But von Braun's career as a rocket scientist has just begun. He and 6,000 other German scientists and their families are shipped to America, along with 100 complete V2 rockets.
Under the Americans, he had the possibility to pursue his research in the direction he had always wanted to go, which was towards the direction of space travel.
America sent aloft its first Earth satellite.
In 1958, a rocket based on the V2 sent the first American satellite into orbit.
Von Braun becomes a hero of the American space age. And the irony of this is von Braun's program kills tens of thousands of laborers and thousands upon thousands of Allied men and women. His Nazi past is almost entirely glossed over.
Von Braun was feted by President Kennedy, and he finally achieved his life's ambition when his Saturn V rocket put Neil Armstrong on the moon.
We have a
In 1969, NASA gave him its highest award, the Distinguished Service Medal. President Ford awarded him the National Medal of Science in 1975.
It's one small step for man, one giant leap for mankind.
His V2 may not have won the war, but it ultimately conquered space and changed the course of human history.
To learn more about this program or any of the other episodes in this series, visit us online at pbs.org/Nazi Megaweapons. Nazi Megaweapons is available on DVD. To order, visit shoppbs.org or call 1-800-PLAY-PBS.